MCP stands for Model Context Protocol, and it's an open source framework which was created by Anthropic. It was published in late 2024, and it sets the rules of how LLMs integrate and share data with external tools and services. And why should you even care? If you or your company is interested in providing data for AI agents to use, then this is highly relevant for you. So MCP essentially allows AI agents to move beyond their static trained data and become agents that can perform real-world tasks. Let's look at an example. Imagine you have an LLM to perform some mathematical calculation. Perhaps it can solve this well by default, but it's much better if the LLM were to call some calculator and make it perform the calculation. And then it would just return its output. Now, before MCP, you'd need to take each such service and connect it to your LLM using the API of the service. But now, thanks to MCP, the way the LLM connects to services is standardized. Okay, so how does the architecture look like? MCP follows a classical client-server principle. So we have an MCP host, which contains multiple MCP clients. And each of these MCP client has a one-to-one connection to an MCP server. But this connection is dual way, which is very important to remember. For example, Visual Studio Code acts as an MCP host. When Visual Studio Code establishes a connection to an MCP server, Visual Studio Code creates an MCP client object that maintains the connection to an MCP server. But when Visual Studio Code connects to another MCP server, then it creates an additional MCP client object to maintain this connection. This is what I mean by having a one-to-one relationship of MCP clients to MCP servers. But the connection itself is a two-way connection, so clients get data from servers, but servers also get data from clients. By the way, these servers can run locally, for instance the local file system MCP server, or somewhere remotely in the cloud. If they run locally, then they communicate by default with the standard input and output, and if it's a remote server, then by HTTPS. But let's dive more into details. There are three essential capabilities that an MCP server can expose. These are called primitives. These primitives are tools, resources, and prompts. The tools primitive are executable functions that AI application can invoke or call. So these are operations the LLM can trigger, for instance, performing the calculation, for instance, a multiplication on a calculator or sending an email. The resources primitive can be used to provide context information to the large language model. So this is not a function that the LLM can trigger, but just data that the AI model can access for context or information. To stick to our calculator example, resources could include a live history of previous calculations. Or it could include live weather data, which is put into the resources to retrieve by the LLM, or a summary of the latest emails. The prompts primitive is a collection of reusable templates. So these are predefined structured conversational templates, kind of like pre-packed scripts that allow for repeatable interactions. So to find the roots for a quadratic equation, for instance, we could create a prompt which would act as a pre-packed script or workflow to do that. So we don't need to call the multiply, divide, and root tools, but we could just call this prompt and get the job done. Basically, we use prompts to account for complex repetitive workflows. All these primitives have associated functions like tools/list, resources/list, and prompts/list to allow the client to discover available primitives. Tools/call, resources/read, and prompts/get are used to actually trigger the tool or retrieve the resource or prompt template. There are also primitives exposed by the client that the server can access. Sampling/complete, elicitation/request, and notification/log. Sampling/complete allows the MCP server to request the client's AI application, so the LLM, to generate a completion. A server can use these generation capabilities of the client's LLM without needing to integrate or pay for their own language model. Also, it keeps the server implementation model independent. This can also be a security concern, so it's important that the server correctly validates the responses. Elicitation/requests allows the MCP server to send a request to the client to prompt the user for additional information or confirmation. So if the server operation requires user approval, for instance for a sensitive action, this primitive can be used. And notification/log allows the MCP server to send log messages to the client host application. But all these primitives are not necessarily required. There can be MCP servers which only expose resources or only tools and so on. The MCP protocol also supports notifications, for instance when a server's available tools change, such as when a new functionality becomes available or existing tools are modified. The server can send tool update notifications to inform connected clients about these changes. Let's take a closer look at the tools. Once the client called tools/list, each tool object in the response includes these three fields. Name, so a unique identifier for the tool, it should be named in a detailed manner. Title, a human-readable display name for the tool that clients can show to users. Description, so detailed explanation in text of what the tool does and how the LLM can use it. And input schema, a JSON scheme that defines the expected input parameters to trigger the tool. Then, after executing a call, the MCP server returns this response. Content, an array of tool responses. These can be texts, images, or other types. Content types, for each content object, the type is returned, for instance text, if the response is of the type text. And structured output, the response also includes information that the client LLM can use as context for describing the interaction with the MCP server. But how does this work inside the client application? So as soon as the LLM decides to use a tool during a conversation, the client application, so Visual Studio Code for instance, notices the tool call, routes it to the correct MCP server, triggers the call, and returns the results back into the LLM as part of the conversational flow. So you can see that this gives the LLM the ability to take real actions.